Okay, so this is a functionality test / demo for ROS version 21 now with bumper functionality. So we are currently connected, and if you wanted to see everything available to us, you would just do ROS topic list. So we can monitor the bumpers, as just mentioned. We can send command velocity messages, so that would send an angular radians per second message or a linear meters per second message. We can monitor the right and left wheel velocities independently, both measured in meters per second, and we can monitor where it is in space using TF. Alright, so if you wanted to check out what was going on with the bumpers, you would do ROS topic echo, and this is just echoing back whatever is going on with the bumpers. So currently nothing is happening. There you go. If I hit the bumpers, you can see they are shown. You can hit multiple at the same time if you want to, and these are coming out in an array, that way you don't have to open up 6 of these. So bumper functionality, check. And then if you want to see what's going on with the control loop for the velocities, you can do that too. So this is going to be the right wheel. I'll move this. And this is the left wheel's velocity. And this is where it is in space. So there you go. And if you wanted to make it drive, you would publish a command velocity. And it's a twist type message, and we have linear X and angular Z are going to be what we're going to use as our commands. So if we say drive forward at 0.15 meters per second, we should be driving at 0.15 meters per second. As you can see, obviously it can't drive at a perfect 0.15. This uses a PWM signal of 0 to 255 and tries to get as close as it possibly can. Here you can see our X increasing, our Y theoretically should be 0, but it is not, because again these are not perfect values. But what are we at? We're at about 4 meters with 0.03 meters of deviation, so that's like a 1% deviation. So that's pretty dang good. Now if you wanted to see what was going on visually, you could use ROS launch rslk world.launch, and this will load up the simulation stuff. So we got gazebo in the back, we got RViz right here, and it loads up using a fixed frame of ODOM. It loads up the robot model, and these are, let's see, there we go. So, yeah. What did that do? Oh, okay. I guess I paused something, but so reset it. Let's see if we can. So that is the robot model, and it, as you can see, doing pretty good. That is the error. So being that we are pretty daggone far out, what are we? 16 meters, and it's only off by 0.12 meters. So that's a very good, you know, it's driving very straight. And if you wanted to get rid of the model, you could do that, and it just helps show the difference in error between the two. If we you wanted to. You can also send these in reverse. Sorry. And if you do this, hopefully, there you go. So you saw it jumped up to a negative 0.29 for a quick second, and then it dropped, which we can scroll up to. So this is the control loop. So we were going 0.15, then -1, -2, -29. And I mean, these are coming so fast, that was like a fraction of a second before it got to the -0.15. The way the control loop's working is it actually will, proportional to how far it is from the desired velocity, it will adjust the current PWM signal to it. And so let's see if we can get this. I'm not good at the camera control, but there they are, driving pretty much in a perfect line backwards. Now if I was to slow down that wheel, it obviously it slowed down here, and then it overcompensated a little bit. Now we're driving backwards, so that threw it off track a little bit. But yeah, and okay, and so kind of do show the error accumulation between theoretical and real world driving, aka like, you know, using dead reckoning. For example, we have two odometry transforms coming out. So we have chassis encoder, which is measuring where it is in real space using the encoders, and we have chassis, which is theoretical, as previously mentioned. So if we were to say drive in a straight line, you can already see a little bit of error accumulation there. And then if we're to say, hey, go ahead and turn, and now drive straight again. So theoretically, that's where it should be, but in reality, that's where it's going. And as you can see, it's not even driving in a straight line; it's turning slightly. So these are it's not going perfect.